what does the graph of e to the x actually even look like? Well, you learned from the last video that e is about equal to 2.718 and then some more. So e is somewhere in between 2 and 3. So it should look somewhere in between the graph of 2 to the x and the graph of 3 to the x, right? Because when x equals 0, 2 to the x equals 1, and when x equals 0, 3 to the x equals 1. When x equals 1, 2 to the x equals 2, right? 2 to the 1 is 2. And then when x equals 1, 3 to the x equals 3. So e should be somewhere in here, right? Shouldn't it go to here, about 2.718? So let's go ahead and take a look. There you go, there's e to the x. Sure enough, it gets on e right there at, right when x equals 1, y equals e. And then as it goes up, it would be e squared and e cubed. And so that's just really 2.718 and then some, cubed, squared, and so on and so forth. But what you learned is the coolest part about e, and the most important part about e that we care about, is that it works really well in calculus because the slope at any given point on this graph is equal to the value at that graph. So say I pick this point right here. It has an x value of 0.836 and a y value of 2.307. Well, the slope at this point is 2.307. So that's really unusual because it's not the case in most other instances. In most other instances, the slope of a point, so slope is rate of change. We're going to learn that here in a little bit in the next unit. But the rate of change at any given point is not really ever equal to the function itself. So it's kind of cool, and any given point on here, the slope is equal to the actual function value. So it's 1.47 here, 2.838 there, and so on. The other awesome thing is that the area under the curve, which means, so if I took the area under the curve, so from this point right here, and I drew down and over, and I shaded in all of this area all the way to infinity, if I shaded all of that, the value of all of that, if I added that all up, the area would be 2.718, or e to the x. So that's what's so cool about e, and if you just notice, it's just an exponential function. It's no different than any other exponential functions we've been dealing with. It's just an exponential function with a base of 2.718 instead of their numbers.